Let's talk about the second type of the machines, which are the pulleys. The pulley is a simple machine that consists of a wheel over a rope or wire. So it has like wheel, and around the wheel there's a rope that's going around the wheel. Here we have a block as an example, and here we have, this is a load, and here we have the input force. That's when you apply on the first wire or on the first rope, you push the load up. On the second, you pull it down, so the load will going up. That's why we say the pulley change the direction. Now, before talking about the type of pulleys, let's here watch this video.
The pulley. The pail of water that Jack and Jill had to fetch was not on top of the hill at all. It was actually at the bottom of a well. Unfortunately, it was too heavy for either of them to pull up. What they needed was a simple machine to give them a mechanical advantage. No, the inclined plane doesn't help. Nor does the lever. Nor the screw. What other sorts of machine are there? Ah, yes, the wheel. But what's Jill doing with it? She is arranging the wheel so that it will revolve on an axle stuck in that post. Very good. Jill's just rediscovered another sort of simple machine. A wheel that, instead of being all of a piece with its axle, can revolve freely around an axle. Since this type of wheel is used mainly for pulling things, it's called a pulley. And Jill can hitch the rope around it and use it to pull. No, Jack can use it to try to pull the pail of water up. That's funny. He needs just as much force to try to pull the pail of water up this way as he did trying to pull it up the other way. I wonder if there's a better way of rigging the pulley. Amazing. How did Jill manage it? Both she and Jack only had one pulley to work with, and yet Jill was able to pull up the pail with half the force that Jack needed. Well, when a pulley is set up like this, it's called a single fixed pulley. All it does is change the direction of your pull, but it doesn't reduce the force you need. But when a pulley is arranged like this, it's called a single movable pulley. And it halves the force you must exert, because the pail of water is now, in effect, being lifted by two ropes instead of one. It's as if two people were lifting the pail. And it looks as if we're getting something for nothing again, doesn't it? But of course we're not. If we compare the distance that Jill raised the pail with the amount of rope she pulled, we see that it's the same old story. What she's gaining on the force, she's losing on the distance. The distance that she pulls the rope is twice the distance that she raises the pail. But the way Jill used the pulley is still twice as effective as the way Jack used it. There are lots of other ways of combining pulleys. The pulley system that Jill finally rigged up for herself. She had to pull the rope 3 meters for every meter that she raised the pail of water. In a sense, she'd become 3 times as strong as Jack. And now you know why Jack fell down and broke his crown.
Bill Nye the Science Guy.
Now this rope is attached to a crane. And a crane uses pulleys. Simple machines. Of course, they're big simple machines, but they're simple machines. Science!
Say you're building a treehouse and you needed some stuff. Say the stuff was really heavy. What would you do?
I'd use pulleys. A pulley makes things easier to lift because it spreads the work. See this rope? Before it just used to go from me to Cammy. But now it goes from me to Cammy to me and then back to Cammy. Now she's gonna have to pull a whole lot more rope to get stuff up here.
But more rope means I won't have to work as hard each time I pull down. So now I can lift something he can't. Here it comes.
With a pulley, she can pull really heavy stuff all the way to the tree fort.
Pulleys. No sweat.
Back in the 1800s, all these cable cars used to be pulled by horses. Okay, the cable cars operate by a bunch of levers and pulleys, which are very simple to operate and maintain. Now I'll take you down below and show you how the grip works. These are the giant pulleys that pull the cable underneath the streets of San Francisco. There's many cables and pulleys that take them around curves and up and down the hills. We're in the sand. Oh.
Okay, here.
Come on.
Absolutely.
That's it. So the pulley is a simple machine, as I told you, that contains a wheel over a rope. We have three types of pulleys: fixed pulley, as you see on the video, movable pulley, and a combination of fixed and movable, which we called it block and track. Let's start now with the fixed pulley. A fixed pulley is attached to something that doesn't move. Here, this is the pulley. Here, this is the pulley, and the pulley here is attached to something that doesn't move. That's why we called it fixed pulley. Now, here we have a force that you pull the pulley down, and the load will go up. So that's why, as I told you, here, this is the force input. Here, when the load will going now up. So that's why the pulley is changed the direction. As we
Teacher?
said on the previous, yes, miss.
Teacher, where's the force input?
Here,
Okay.
okay, and the load will going up. So why we call it fixed? Because as I told you, here the pulley is attached to something, to the wood, to the metal, to anything. It's attached to something that's fixed. Now, pulley, from its name, that's you have to pull the load. Now, let's talk about the second one, which is the movable pulley. The movable pulley here, look at it. Here is the movable pulley. Oh, here is the pulley. The pulley here is not attached to fixed to something. Here it's moving. So that's why we called it movable pulley, because the pulley now it is moving. How it will be like if you have dam here, you want to bring the water from it, you have to push the force up, unless now you will, or we like you have to push something up, unless the load will going up. This is, we called it here movable pulley. And the third one, which is a combination from the movable and the fixed, one of the pulleys is fixed, and the other pulley, it could be two pulleys or more than. So one is fixed and the other one will be movable. This type of system, we call it a block and tackle. Here we have it like this is the effort, you apply it here, or this is the input force. Here, the load, it's going down as an example. And here we have two pulleys. This is the first one, which is fixed, and the second one, which is movable. Now, let's talk about the mechanical advantage for them. Let's talk about the fixed pulley. As I told you, the fixed pulley is attached to something that doesn't move. As an example, like the elevator or the flagpole. You know how to raise the flag. This is an example of a fixed pulley. Now, the mechanical advantage here is equal 1 because once you apply the force that you apply it is the same force will be the output. So the output force over the input force will be 1. And here, as you see, this is a fixed pulley. So the mechanical advantage doesn't increase the force because once you have input, once you have the output. Now for the second one, which is the movable. The movable, as I told you, from its name, that's mean that's attached to something that is moved, or the pulley here is not moving. The example, such as the bike left in the store of garage, like this example here. Once in some countries, they attach bikes to put it on a place. So when you want to bring your bike, you will pull the wire. Another example, like the cable system on the board. Now, let's talk about the mechanical advantage. The mechanical advantage here, it's 2. Why it's 2? Because since you have a movable pulley, so the output for, I mean, like when you increase 1 Newton, the output force will be 2 Newton. Because because here you have, when you push it, when less force, the output force will be greater. So the mechanical advantage will equal 2. Because the input force, the output force here is greater than the input. As you see in the video, the boy tried the fixed. When try the fixed, he found that he needs a greater force to push or to bring the bucket. But when the girl come and solve the problem, as usual, the movable pulley, she used the movable. The movable tell you that if you, like when you have the boy, you try 1 Newton, he get up it with 1 Newton force. But the girl, when she used the movable, she act with 1 Newton, but the output force will be 2 because she used the movable pulley. And the third one here, which is the combination of them, as I told you, which is the movable and the fixed together, which we called it block and tackle. Add these examples here. Now, look at here. Sorry. Let's now try to cut it like this. Like you cut it now. So here, how many ropes we have? We have 4. And down here, it's hang with 1. So that's mean if you act with 1 Newton as an example, the output force here you have it with 1, the output force will be 4 according to the number of wires. So the output over input force will be 4 over 1, which is greater than 2. So the mechanical advantage here will be greater than 2. So if you act within 1 Newton only, the load, and the load is 4 Newton. If it is 4 Newton, you have to bring 2 pulleys with 2 mechanical advantage for it. So if it is 4 Newton, you need only 1 Newton to push the load. That's why here sometimes you go and bring this type of pulleys. Is it clear? These are the pulleys, as I told you. Now, here we have the type of pulleys: fixed, movable, and block and tackle. The fixed, as I told you, the mechanical advantage here is 1. For movable, the mechanical advantage is 2. And the block and tackle, the mechanical advantage is greater than 2, as we have 4 rope segments that apply 4 Newton to the load. Is it clear?
Yeah.
Yeah.
Yes.
Right now,